First law of thermodynamics. First law of thermodynamics is nothing but law of conservation of energy. What is law of conservation of energy? So, law of conservation of energy or first law of thermodynamics states that energy can neither be created nor destroyed. Energy can neither be created nor destroyed, but one form of energy can be changed into another form of energy. Therefore, mathematical relation for first law of thermodynamics is delta U equal to Q plus W. Delta U equal to Q plus W. What is delta U? Delta U is change in internal energy. Change in internal energy. Internal energy U, absolute value of internal energy U cannot be found, but only change can be determined. Change in internal energy of the system can be determined. Q is the heat absorbed or given out. Q is the amount of heat energy absorbed or given out. W is the work done by the system or on the system. Now, in the previous class we discussed about the significance of Q and work. So, recollect the nature of Q and work. So, heat, sign of the heat. So, Q is positive or greater than 0, indicates that heat is supplied to the system. Heat is supplied to the system, or system absorbs heat. System absorbs heat. If Q is negative or less than 0, heat is given out by the system. Heat is given out by the system. Or heat is lost by the system. In the same manner, work. Let us recollect what we discussed about work in the previous module. Work is positive. If work is positive or greater than 0, then work is done on the system. If W is greater than 0 or positive, it is understood that work is done on the system or compression of gas. If W is negative or less than 0, work is done by the system. Or expansion of work. So, you have to keep this in mind. So, this in case of heat also, this is so this sign convention of heat and work are most important, and you have to remember thoroughly this sign convention of heat and work. In the previous module we discussed about the derivation of work done in reversible as well as irreversible process. Reversible process means multi-step process, whereas irreversible process is a single step process. So, work done in a irreversible process. Irreversible process means single step process. In single step process, W equal to minus P delta V. On the other hand, reversible process process. A reversible process means multi-step process. Irreversible process is multi-step process. So here W equal to minus 2.303 nRT log V final minus V initial. So this is the work done in a single step and multi-step process, reversible and irreversible process. Let us extend the applications of first law of thermodynamics under various conditions. If free expansion takes place in vacuum, see, this is a closed container and this is the gas. So gas expands. So when gas expands into vacuum, the free expansion during free expansion in vacuum, W work done, W equal to 0. Therefore internal energy delta U equal to Q plus W. Internal energy delta U equal to Q plus W. Therefore internal energy U equal to Q plus 0. Right. So this is nothing but QV. Delta U equal to QV. QV means heat absorbed at a constant volume. QV is the heat absorbed at a constant volume for a given change in volume delta V. For a given change in volume delta V, W, that is work done, is maximum. The work done is maximum if P external is maximum. But for expansion, P external is less than P internal. If the external pressure is less than internal pressure, then gas expands. That is, for getting the maximum work, P external is infinitesimally small. Infinitesimally small means the external pressure is very, very small when compared to internal pressure, then maximum work takes place. Therefore, these conditions, what conditions? The external pressure is infinitesimally smaller when compared to external pressure. These conditions are close to reversibility. Therefore, work reverse equal to work maximum. It may be noted that if P external is equal to 0, then work done is equal to 0. Therefore, during the free expansion of an ideal gas, no work is done. So this we already discussed. Therefore, free expansion of ideal gas in vacuum is W equal to 0. Therefore, this is the important point which you have to keep in mind. Right. Now let us see the next condition. For isothermal reversible as well as irreversible process, change in internal energy delta U equal to 0. So delta U equal to Q plus W or Q equal to minus W. Q equal to minus W. So for irreversible change irreversible change equal to Q equal to minus W is equal to P external into delta V, P external into delta V. And for reversible change W equal to minus 2.303 nRT log V final by V initial, for expansion of ideal gas in vacuum, ideal gas in vacuum, W equal to 0, delta U equal to 0, therefore Q equal to 0. For adiabatic process means delta Q equal to 0, heat exchange is 0, therefore delta U equal to work, this work is referred as adiabatic, work adiabatic. For isochoric process, delta V equal to 0, therefore delta U equal to QV. For isochoric process, since delta V equal to 0, so delta U equal to QV. Now based on all these discussions, let us do some problems. A system gives out 20 joule of energy and also does a work of 40 joule. What is the change in internal energy? See, as per the sign convention, heat given out Q is negative, therefore Q equal to minus 20 joules. Similarly, work done by the system and also does a work, that is work done by the system, W is also negative, therefore W equal to minus 40 joule. Now internal energy delta U equal to Q plus W. Q is minus 20, W is minus 40, therefore this is equal to 60 joule. Now let us change the conditions. See, the same problem, a system gives out 20 joule of heat and a work of 40 joule is done on the system, work is done on the system. Then what is the change in internal energy? Delta U equal to how much? So just remember, in the previous problem, heat given out Q is minus negative, heat work done by the system is negative. So here, so heat is given out, therefore Q equal to minus 20 joule. It is as usual. Here work is done on the system, as work is done on the system, W equal to positive, that is W equal to minus plus 40, therefore delta U equal to Q plus W equal to Q is minus 20, W is plus 40, equal to 20 joule of energy. Now let us take in a different way. Same problem, similar type of problem, but conditions are different. A system absorbs 20 joule of heat. A system absorbs 20 joule of heat and 40 joule of work 40 joule of work is done by the system, and 40 joule of work is done by the system, then what is delta U? So here system absorbs heat absorbed equal to heat absorbs is plus Q, therefore Q equal to plus 20. Work done by the system, work done by the system, work done by the system means W is negative, so W equal to minus 40, therefore delta U equal to Q plus W. So this is Q is 20, W is minus 40, this equal to minus 20 joule. So in this way, in three problems we discussed about the different conditions for heat and work. So keep the point in mind, heat absorbs is positive, heat given out is negative. Work done on the system is positive, work done by the system is negative. That is, for expansion W is negative, for compression W is positive. Now let us do one more problem. A gas absorbs 150 joule of heat and expands against the external pressure of 1.5 atmosphere from 1 liter to 2 liter. What is the change in internal energy? So here W delta U equal to Q plus W. So here heat is absorbed, heat absorbs means Q is positive, therefore Q equal to 150 joule. So here work done during expansion is negative, therefore W equal to minus P delta V. What is the pressure here? 1 atmosphere. Delta V, that means change in volume. Change in volume from 1 liter to 2 liters, that is 1 liter. Therefore 1.5 atmosphere into 2 minus 1 liter. This is nothing but 1.5 liter atmosphere. But 1 liter atmosphere equal to, this equal to, here this is minus. So this is minus 1.5 into 101.3 joule. 1 liter atmosphere equal to 101.3 joules. Therefore if we multiply, we get minus 151.95 joule. Now internal energy, delta U equal to Q plus W. What is Q here? Plus 150, and what is W? Minus 151.95 joule. So this is joule, this is minus 1.95 joule. Therefore during this process the change in energy is minus 1.95 joule.